All right, this video is about u-substitution. But first, let me talk a little bit. And I have a quote for you to read. Please read that quote. So why did I bring that quote? Is because in my experience in Cal 2, students try to learn the new material in Cal 2 without the previous knowledge from Cal 1. And one of those is u-substitution. So you really need to know u-substitution to understand the new stuff. So let's go and refresh it. So before we start, remember to enter learning mode, to use your metacognition to adjust your mindset, move away any distractions, and this, which is very important to me, pause the video to take 3 deep breaths from your belly. Inhale in a count of 4 and exhale in a count of 6. After that, you should feel relaxed, alert, open, focused, positive, and feel free to add any expression that tells how you feel. With that awareness is the best way to work your any learning. If at any point you notice your mind wandering off while watching the video, it's okay, normal, that happens to everybody. Just notice it. Do not judge yourself, don't start saying things to yourself, and gently go back to the place where you were understanding and continue. That only takes a little time, okay? So let's start our business now with u-substitution. So what is u-substitution? Let me write up here. U-substitution is, remember the chain rule when you were deriving? If you had a composition, F composed with G, and you want to derive it, what you have to do is take the derivative of the outer function, keep the inner function there, and then multiply by the derivative of the inner function. So what u-substitution is about is going back from the chain rule. It's trying to go back. So remember, if this is the derivative of that function, the integral is what's inside here. Okay, so that's what we're trying to do. Go back from the chain rule. Why would do that? Okay, so imagine you're integrating this. Easy, distribute, and it's all about power rule. Okay, suppose you're doing this one. Okay, it's doable. You can cube it, distribute all of that, and you use power rule. A little tedious, but it can be done. But now, try to do this. Okay, I don't want to raise anything to the 50th power. No. So that's where substitution comes in. Why we do it? Well, we want to integrate functions. We want to find the antiderivative for so many applications. And for math itself. Okay. So what is the u-substitution? So you're going to change your variable according to this. The first thing you need to know in applying u-substitution is there must be a function inside another function, and then the derivative must be multiplying that in order for us to be able to apply u-substitution. So the first thing you have, when you're presented with that integral, the first thing you have to ask yourself is there any function inside another function? So when you say inside another function, it could be inside a square root, inside a sine or cosine. It could be inside a power. It could be a denominator. So that's what's inside. And then the derivative of that function you found inside must be multiplying in the expression you're looking at. Like here, you see, this is inside the 50th power. And then we have here the 2x, which is the derivative of this, what's inside. What's the derivative of x squared plus 1 is 2x. So here, u-substitution is going to work. Okay, that's what you're looking for. And this is how you proceed. Well, it's just a change of variable. You take u to be the inside function and then derive it on both sides with respect to x, and then solve for dx, and then you make your substitution. So you substitute in u for x squared plus 1, and you get this part here. So substitute that in here. And then substitute what? Keep your 2x and substitute dx. dx is du over 2x, substitute that there. Because the derivative was already there, and we're solving for dx, what you get here is the derivative of the inside function, so it will cancel out. In that way, we arrive to an integral that is only in terms of u. And that is the next step. Once you do find your u, you do this procedure, you do the u-substitution, you cannot have any x's left. Everything has to be in terms of u, okay? After you do that, now here you apply just the power rule, add 1 to the exponent and divide by the new exponent. But remember, you have to go back to x. So replace the change you've done. Okay? And that's what u-substitution is all about. The rest is just what? Practice. Practice. Repetition is key. Okay? What you're going to find now is a worksheet I made to practice u-substitution. So it is uploaded in the shell. And here are the problems. Some of them are done to guide you. But then you're going to find all of them done, like step by step, as you scroll down. So you're going to find all of this just like that, you know, the problems now, and then you're going to find the same thing with the answers. And because you are in Calc 2 and you are adults, you know that you have to try it before you even see any answer, or before even I say it here in the video, okay? So let's start going over the worksheet. And here, the first one, piece of cake. The inside function is right here. It is in the denominator, and it is inside a square function. So this is inside. What is the derivative of this one? It involves an x squared. You discard, I forgot to say that before, you discard the constants. That will be taken care by the procedure. Okay, so you don't care about the constants. If you see an x cubed here, this is 0, the derivative is 0, and then this is 3x squared. You don't care about that 3, but the x squared is there, so this is going to work for u substitution. Then you take your u to be the inside function, derive it, solve for dx, and substitute. This piece is just u, you square it, keep your x squared, and then substitute dx right there, and you get du over 3x squared. And of course, because the derivative was there, it cancels out. Pull out the 1/3, and this is all you have. The easiest way to integrate this is you use the negative power and apply the power rule. Add 1 to the power and divide by the new power, and you get negative 1 over 3u plus c, and then put back your x. You have to go back to x, which was 1 plus x cubed, and there you go. This is the integral. Okay, so I'm going to go over this really quickly just to make you note, but please, again, try to do it before you watch this part of the video. Try to be really conscious about your learning. Okay, so what's inside here is 5x cubed. Sorry, 5x squared, okay? So what is the derivative? 10x. Oh, the derivative is here, even with the 10. So this is going to work. Substitution, u equals 5x squared minus 4. I'm not going to go on detail over every problem. That would take a video of an hour and a half. So, but just realize what the change would be, and then you do the procedure, okay? Just replace the u, do the u-substitution, and be aware the last integral you get here has to be all in terms of u. No x's around. Okay. The next one, e to the e to the 1 over x squared. So what's inside another function? Recall e to the x. The inside of e to the x is where the argument is. Think about evaluating the function 1 over x. If you were to evaluate this at 1, say, at x equals to 1, where do you go first? Right here. So that's the inside of the function. The first thing you do when you replace a number, for example 1, okay? So the inside of e to the x is the argument is here. So 1 over x is inside e to the x. And the derivative of 1 over x, if you recall, is negative 1 over x squared. And it is indeed multiplying the composed function we have there. So the u substitution is going to work, and you take u to be 1 over x. And then you do the rest. The next one is really straightforward because the derivative of ln x, if you recall, is 1 over x. And it is indeed multiplying ln x. So if you take u equals ln x, then du is 1 over x. And it's done. It is multiplying there. So u substitution is going to work. For the tangent, for example, it's convenient to write it. And for any trig function, you might need to use an identity first. In this case, it works. It's sine over cosine, right tangent as sine of x over cosine of x. And then the cosine is in the denominator. So if you take u to be the cosine, then du is the derivative of the cosine, which is negative sine. You see? You don't care about the negative sign. The procedure is going to take care of that. But your derivative is up there, so it is going to work. You see? This equals, now let's do the u substitution. Keep your sign there. Cosine x is u, and dx is du over negative sine x. So cancel out the signs. The negative sign outside, that's the integral of 1 over u du, and that is just negative ln of u plus the absolute value of u, and put back your change. Remember, u is cosine x, so this is negative ln absolute value of cosine of x plus c. It's not a big deal. Here again, the u is the inside of this function. This is a power function. Any power function, 2 to the x, 3 to the x, 5 to the x, or whatever you find there, this is the inside. So the inside is here, and the derivative of x cubed is x squared, which is there, so this is going to work. Okay, now we start looking at, those were straightforward applications of the u substitution. Straightforward u substitutions. Okay, now this is a little different because, well, not different, but I have to recall that when you're doing integrals, you start by looking at the table first. If the integral that you're taking is in the table, you're done, okay? If not, you apply u substitution. That's the only way you know how to integrate so far. So u substitution is not going to work here, like straightforward, because this x to the 4th power, so the derivative of this here is 4x cubed. And so you need x cubed up here, and you don't have it. You see? So u substitution straight is not going to work here. Okay? Then let's go on and look at the table. There's a guy in the table that resembles a lot of this, which is 1 over square root of 1 minus x squared dx, and that is arc sine of x. That is on the table. So we can use it, of course. Now, how can we change this integral to look like that? Oh, I need a square here, but I have a 4th power. and this is 1 degree less. What if we take u to be x squared? Then u squared is going to be x to the 4th power, and then I can replace this by the variable squared, and it resembles more that integral, right? Then, sorry, du is 2x dx, and then dx is du over 2x, and we do the substitution. Keep your x, and then u is just 1 minus, sorry, square root of 1 minus x to the 4th power is just 1 minus u squared, because x to the 4th power is u squared. And then replace the x, which is du over 2x. Cancel out the x's, bring out the 1/2. And you see what is left there? That is on the table. Sorry. That is on the table. So we use the table. It tells us this is arc sine of u plus c. I don't have space here, but then go back to x. Go back to x. And then the integral is going to be what? Arc sine of, and then instead of u, you write x squared plus c. Okay, number 10 is just dealing with the exponents. So very easy. X, that's the first power there, and then take away the square root of 3 and do x to the 1/2, and then subtract. So you get 4 over root 3, and then the integral of x to the 1/2. And just do that. Easy. On the next one, you can see that the derivative of this is here. So if you take u to be this entire thing, its derivative is 3 sine 3x. So just take u to be 5 plus cosine 3x. Then du is the derivative of the cosine is the negative sign. And then the chain rule puts up with 3, right? Sine 3x. And then when you do the change, what you get is sine 3x, keep it there, not same, sine 3x over square root of u. And then du, sorry, there's dx there. When you solve for dx, du is going to be just, dx is going to be just du over negative 3 sine 3x. Cancel sine 3x. Take the negative sign and the 1/3 out. Then you have u to the negative 1/2 power. Okay. Integrate. Add a 1, so you get 1/2 here, divided by 1/2. Let's see. So that is just negative 2/3 square root of u plus c, and go back to x. So negative 2/3 square root of 5 plus cosine of 3x plus c, and we're done. Okay, next one, very easy. The derivative of 4 minus e to the x is here, multiplying, so we're fine. Take u to be 4 minus e to the x, and well, that's it. Du is going to be negative e to the x dx, and when you put the change, keep the e to the x there. 4 minus 4x is u, and dx is going to be du over negative e to the x. Cancel that, bring the negative sign out. So that's 1 over u du, which is just negative ln of the absolute value of u. And then put back your change. Absolute value of 4 minus e to the x plus c. Good. Easy. On the next one, again, just distribute, put your powers, like rewrite this as 2x to the 2/3 plus 1, and then x, write it as x to the 1/2, and just add the powers and apply the power rule. That's very easy. Next one, again, when the pattern is so immediate that you can see that the derivative of the inside function is there, it's going to be quite easy, because then u here would be x squared, and then du would be 2x dx, and the x is going to cancel out like we've done several times so far. When you have this type of integrals where you have sine and cosines there, so the technique here is save that cosine, because that cosine is the derivative of the sine. So if you take u to be the sine, then you're sure that the derivative is there. Substitute u here, and that's it, because cosine x dx you replace by du. You replace it here. Then integrate and go back. Easy. And even if you have a larger power, same thing. Easy, because the sine is the derivative of the cosine. So if you take u to be just the cosine of x, du is going to be negative sine x dx. And when you do this part, when you do the substitution, you would get u to the 5th power. And then this is exactly that, except for negative sign. So this is going to be negative du. Just take the negative sign out, u to the 5th power du. Negative u to the 6th power over 6 plus c. So that's negative, and go back. Cosine to the 6th power x over 6 plus c. Same thing here, because what? The derivative of the tangent is the secant squared, completely there. So when you take u to be tan x, du is going to be secant squared x dx, because that's just the derivative. So you replace all of this by du. And then this is u to the 3rd power, and you know how to continue that. Again, you have the answers below. Same thing here. That sign is inside the cosine. Sorry, that sign is inside e to the x. And so if you take u equals sine of 5x, then du is cosine of 5x. And remember, the inner derivative brings a 5 here. It's just by a factor of a 5. So you're going to get, exactly, you're going to get 1/5. No, yeah, it's correct. You're going to get 1/5 at the beginning, but you proceed the same. Okay, now is when it comes, we have to do certain tricks to make it work. So you see, here you have x minus 1 to the 5th power. That's the only function that's inside the other function. The derivative is 1, but yet we have some more x's here. So if we can put u in terms of x, or sorry, x in terms of u, we can replace it here, and we would be done. So if we take u to be what's inside, which is just x minus 1, then du is dx. So when you're doing the change here, the x plus 3, you can't do anything yet about it, but the u is going to be u to the 5th power, and du is dx, so this is just du. Now, we cannot leave an x there. We cannot integrate like that, so we have to make this in terms of u. But that's easy, because if u equals x minus 1, then x equals u plus 1. Put the 1 to the other side, so x is u plus 1. And then x plus 3, add 3 on both sides, is u plus 4. Just add a 3 here and a 3 here. Why? Because we want this. We want to replace it here. And we're done. X plus 3 is u plus 4. Keep u to the 5th power du. Distribute u to the 6th power plus 4 u to the 5th power du. Integrate u to the 7th power over 7 plus 4 u to the 6th power over 6 plus c. Let's go back to x. So u is x minus 1 to the 7th power over 7 plus, simplify the fraction, that's 2/3, and instead of u it's x minus 1 to the 6th power plus c. And we're done. Next one is very similar to this one. We take u, of course, to be what's inside, 4 minus x, then du equals negative dx. When we do the change, you keep your x, that becomes square root of u, and then du dx is negative du. Okay, and the only thing we need to do now is replace this x, and we get it from here. Okay, move the x here and the u there, and we get x. It's 4 minus u. And now replace it here. So that's the integral of 4 minus u. Instead of root u, I'm going to write root to the 1, u to the 1/2. And there's a negative sign from the du. And there you go. Distribute. Let me put the negative sign inside now. So that would be negative 4 u to the 1/2 plus 4 u to the 3/2 du. And now integrate. Let me put this is apart. So that's negative 4. 1/2 plus 1 is 3/2 over 3/2 plus 3/2 plus 1 is 5/2 over 5/2 plus c, and then go back to x. So that's going to be negative 8/3. U is 4 minus x to the 3/2 plus then 2/5. 4 minus x to the 5/2 plus c. And we are done. The next one looks more complicated, but it is not really complicated. Look what's inside something. So the only thing I see inside something else is that 3 plus ln x. And now I'll try to figure out what's going to happen. Okay. So you know that the derivative of ln x is 1 over x, and it is here. You see 1 over x is here. So it might work if we can change this in terms of u. So let's try to work it out. What's inside is 3 plus ln x. Its derivative is just 1 over x dx, making dx be x du. So when we're trying to put the change here, so that's going to be u squared, because u is 3 plus ln x, and we have to write this in terms of u, because the rest is this. We have a 4x down there, and then dx is x du. So the x are going to cancel out. The only thing we have to figure out still is how we write 2 minus ln x in terms of u. But we know that u is 3 plus ln x, so you get it from here. Okay? So what we want is negative ln x. Alrighty? Let's first move ln x here to get that negative sign. That would be u minus ln x equals 3. And then what? Move the u to the right. We get negative ln x equals 3 minus u. And we're almost there because we have negative ln x, this part. So we just have to add a 2 to get 2 minus ln x on the left-hand side. So just add a 2 here and here. So what we get is that, we put it here, 2 minus ln x equals 5 minus u. And replace it. 2 minus ln x is 5 minus u. Replace that there. So that's 5 minus u. So that's 1/4. And then you have something that you can deal with. Just distribute and use the power functions. Okay? Again, the answer is below. So you have to know your derivatives in order to be able to do this, because here, again, this is a pretty straightforward one, because square root of x, what's the derivative of root x? The derivative of root x is 1/2 root x. And you see that root x is in the bottom. So when you take u to be 2 minus square root of x, then du is going to be negative 1/2 root x dx. Okay, and so you have it there, right? Except for that negative 1/2 that you're going to put to the front. Okay, e to the x, e to the x. Okay, that, well, I would write it as e to the 2x. Just add the exponents, right? And then u would be just 2x. And then du is 2 dx. So that's the integral of e to the u. E, not u. E to the u. And then dx is du over 2. That's 1/2 integral of e to the u du. And so that's 1/2 e to the u plus c, because the integral of e to the u is e to the u. And then that's 1/2. Put back your change, e to the 2x plus c. So I don't know if you can see this at this point, but I mean, it should be natural, because when you derive a function where x has been multiplied by a constant, when you derive, the chain rule puts the 2 in the front. It will multiply by the inner derivative, which is 2. The integral does the opposite. So when you have a constant multiplying your x, you're going to have that number dividing, because you're integrating now. So I don't know if you recall this, like the integral of sine of 2x dx is going to be what? Negative cosine of 2x, but then you have to divide by 2, all right? Because there's a constant multiplying your x. All right, next one. Again, we have to figure out what's going to be u, right? And well, if you look at the denominator, you see that the derivative of this is there, but there's something else adding here. It comes from here, right? So it's kind of clear that if you take the denominator to be u, what is du? That's going to be the derivative of e to the 3x is 3e to the 3x, and the derivative, why did I write a d there? That's an x, sorry. And the derivative of 3x is 3. So now you can factor that 3, and you get exactly what you have there, the derivative. Okay, the 3, you take it out, that's all. But then that's going to cancel out. Okay. Next one is down there, is pretty straightforward. I don't think I have to go over that. Okay, and now comes the u-substitution using the definite, for the definite integral. That means now we're looking at limits of integration. And there are two ways to do this. You can either go and find the antiderivative as we were doing before without touching the limits of integration. Go up to the antiderivative and put everything in terms of back in terms of x, everything back in terms of x, and then you evaluate, okay? Or, which is kind of the one I like because I don't want to forget to change the limits. I don't want to forget to go back to x or anything. For me, it's safer to change the limits of integrations. So that's what we're going to do here. So again, this is a very simple u-substitution. If you take what's inside here and you do 2 times 4x to the first power, that's exactly what you have multiplying there. So the derivative is there. We're fine. So take that u, du is going to be 8x dx, so dx is du over 8x. But now you have to change the limits of integration. Two things to keep in mind here. If you're plugging in the -1 to get the lower limit of integration, that's going to be your lower limit, even if it's bigger than the top. It's whatever the function is giving you, okay? So you plug in x equals -1 to find the new lower limit of integration here. Where you plug x equals -1? In the change you're making. Okay, so plug in x equals -1 here and you get u. So u is 5. And that's got to be your lower limit of integration. If you start with the lower limit here, some people change it and put it up because it's going to be bigger than the other. No, you don't do that. And for the upper limit, just plug in the 0 again there to find u, and you get a 1. You get a 1. So what happens is that this is decreasing. This is changing the order. It's making the lower limit be bigger than the top limit. And well, put the change in. So this is something you know how to do. Cancel the 8x, and this is what you get. But remember that when you interchange the limits of integration, that brings a negative sign. So to have the lower limit here and the upper limit here, the upper limit being bigger than the lower limit, you just have to multiply by a negative sign. And then just proceed. What's the integral of this? Add 1 and divide by that new number. So that's u to -1 over -1. Multiply the signs, 1 over u. The next part is doing the same thing we were doing before, but taking into account the limits of integration because we're doing it for the definite integral. So it's the same thing. So here you can take, in this case, you can take u to be the sine or the cosine. It doesn't matter. I'm going to take the sine because the derivative is positive. So I won't have a negative sign there. So u equals sine x, and then du equals cosine x dx, and we're going to replace. So sine x is u, and cosine x dx is exactly what I have here, so I can just write du here. The limits of integration are going to change. So what you do is plug in x equals to 0 into here, and that gives us u is sine of 0, which is 0. So the lower limit stays being 0, and the upper limit is pi over 3. That means that u equals sine of pi over 3. Okay, and sine of pi over 3 is root 3 over 2. So we're going here to root 3 over 2. And now integrate. That's going to be u squared over 2 from 0 to square root of 3 over 2. And evaluate. So square root of 3 over 2 squared over 2 minus 0. And that's what? 3/4 over 2. And that's 3/8. Okay. Not a big deal, right? So, I mean, the rest is the same. It's making this video very, very long, but the idea is that you can go to any place you need to see or to watch. Okay. So again, derivative here is simple because if you take u to be x cubed, The derivative is there, so the u substitution is going to work. I prefer to do this one because this looks like more complicated. Let's do that one. So u is what's inside, right? Square root of x plus 1. Then du is 1 over 2 root x dx, and that makes dx be 2 root x du. Okay, so when we put the change in, that's 1 over square root, let me not take that much space, 1 over square root of x, and then u squared, and then dx is 2 root x du. That cancels out, the 2 comes out, and we just get the integral of u to the negative 2 du. Now the limits of integration. The first limit here is 1, so for x equals 1, we want to know what is u, so replace it there. U equals square root of 1 plus 1, and that's a 2. So the lower limit is 2, and then replace the upper limit. This one here, and you replace it again there. So u equals root 4 plus 1, and that's a 3. So the upper limit is 3. We're going to form 2 to 3, and then just integrate that. That's u, add a 1, and divide by the new number from 2 to 3. So that is going to be negative 2. I like to write it like this, and then maybe 1 over u from 2 to 3. So that's going to be negative 2 times 1/3 minus 1/2. That's going to be negative 1/6. And then multiply the signs and reduce the fraction. You get 1/3, right? Good. So I hope you're getting the grasp of this. They look more complicated, but they're not. Not really. You see, if you take u to be the cosine, the derivative is there. So if u equals cosine t, du equals negative sine t dt, and then so when you put in the change, you get u cubed, and then sine t dt is negative du. If you see it that way, it makes it, I don't know, faster, easier. And then do the limits of integration for x equals 0, replace it here, and then u is cosine 0. Okay, cosine 0 is 1, so that's the lower limit, and x equals pi over 2, and that's u, then u equals cosine of pi over 2, and of course cosine of pi over 2 is 0. Okay, so we get negative, because I'm going to switch the limits of integration, u cubed, and then negative du. Multiply the signs, and this is just the integral from 0 to 1, u cubed du, which is u to the 4th power over 4, from 0 to 1, which is 1/4. That's it. Okay. This is the exact same thing. Exact same thing. I think you have it there. This is getting too long. The other one is same thing, because you see when you derive this, you get 2x plus 4, and when you factor a 2, you get exactly what you had on top. So, and that's the last one. Oh my god. Well, let's do that one then. I don't know if you prefer to see the sine, the cosine one. Well, let's do that because that has an identity there. So when you have this, don't go straight to do cosine, u equals cosine, and then no, you have cosine and cosine. You want to see a sine. And you know that the Pythagorean identity tells you that 1 minus cosine squared is sine squared. And that's going to cancel out your root. So first of all, before doing anything, do the identity, right? 1 minus cosine squared x equals sine squared x. And that leaves you with an integral we already did, which is cosine x sine x dx. Okay, easy. And that we already did. Only that you have to change the limits of integration. You use u equals, here the u could be, as we saw before, the cosine or the sine, whichever. And in this case, when you take u to be the inside there, what happens is that when you do the u, you get 2x plus 4, and then you can factor the 2. Oh, I forgot the dx. Zeri. Dx, so you can factor now the 2. Okay? And voila, dx equals du over 2 times x plus 2. Okay? And when you replace here, you have your x plus 2 there, square root of u, and then dx is du over 2 times x plus 2. So the x plus 2 cancels out. The 1/2 comes out here. U to the negative 1/2 du. Integrate. Add a 1, so that's 1/2. And here 1/2. These 2's are going to cancel out. And well, I didn't do the limits of integration. Let's do them. So the lower limit, x equals 1. Replace it. So u is going to be 1 squared plus 4 times 1 plus 7, which is what? 12. So their lower limit is 12. And then the upper limit is 3. Replace it. U equals 3 squared plus 4 times 3 plus 7. And that's 28. So this goes from 12 to 28. 12 to 28. Okay. And then let's continue here. So this is just square root of u from 12 to 28. That's root 28 minus root 12. Okay. And now it's just a matter of writing them better. Like 28 is 4 times 7. And square root of 4 is 2. So this is 2 root 7. And 12 is 4 times 3, and square root of 4 is 2, so that is 2 root 3. You can even factor the 2, whichever. Okay. And we're done. I hope I gave you a very good place to refresh your U-substitution. Again, crucial for your Cal 2 class. Alrighty. Oh, it was good, nice. Alrighty. Bye, see you on the next video.